Hello guys, welcome to another video here on the web fundamentals learning part, and we're currently on the how the web works module, and we are going to treat the last room here, which is putting it all together. This is the last video for that module, putting it all together, and without further ado, let's jump into it. Task 1, putting it all together. Now, putting it all together, from the previous modules, you'd have learned that there's quite a lot of things going on behind the scene when you request a page, or when you request a web page in your browser. Now, to summarize, when you request a website, your computer needs to know the server's IP address. It needs to know the server's IP address it needs to talk to. Now, for this, it uses DNS. Now, your computer then, which is the domain name system, which resolves the name to the IP address. Now, your computer then talks to the web server using a special set of commands called the HTTP protocol. Now, the web server then returns HTML, which is the structure, JavaScript, CSS, images, etc., which your browser then uses to correctly format and display the website to you. So as you can see, you basically request a web page on your browser. The DNS resolves the name to an IP address, and behind here, it's you view the website, but basically it connects to the web server first. Okay. Now, there are also a few other components that helps the web run more efficiently and provide extra features. I've read this, and that completes task 1. Task 2, other components. Load balancers. Now, when a website's traffic starts getting quite large, or is running an application that needs to have high availability, now one web server might no longer do the job. Now, load balancers provide two main features: ensuring high traffic websites can handle the load, and providing a failure or a failover if a server becomes unresponsive. Now, when you request a website with a load balancer, the load balancer will receive your request first and then forward it to one of the multiple servers behind it. Okay, now the load balancers uses different algorithms to help it decide which server is best to deal with the request. A couple of examples of these algorithms are round robin, which sends it to each server in turns, or weighted, which checks how many requests the server is currently dealing with and sends it to the least busy server. Now, load balancers also perform periodic checks with each server to ensure they are running correctly. This is called a health check. Okay. Now, if a server doesn't respond appropriately or doesn't respond, the load balancer will stop sending traffic until it responds appropriately again. Okay. Now, we have what we call CDN, Content Delivery Networks. So now, a CDN can be an excellent resource for cutting down traffic to a busy website. Now, it allows you to host static files from your website, such as JavaScript, CSS, images, videos, and host them across thousands of servers all over the world. Now, when a user requests one of the hosted files, the CDN, which is the Content Delivery Network, works out where the nearest server is physically located and sends the request there instead of potentially the other side of the world. So if you're in the UK, it looks for the server that is close to the UK, US, the one close to the US, and so on. Now, databases. Often websites will need a way of storing information for their users. Okay. Now, web servers can communicate with database to store and recall data from them, and databases can range from just a simple plain text file up to complex clusters of multiple servers, providing speed and resilience. Now, you would come across some common databases: MySQL, MS SQL, MongoDB, GraphQL, Postgres, and more. Each has its specific features. WAF, or what we call Web Application Firewall. Now, a WAF sits between your web request and the web server. Now, its primary purpose is to protect the web server from hacking or denial of service attacks. It analyzes the web request for common attack techniques, whether the request is from a real browser rather than a bot. So it also checks if an excessive amount of web requests are being sent by utilizing something called rate limiting, which will only allow a certain amount of requests from an IP per second. So if a request is deemed a potential attack, it will be dropped and never sent to the web server. So basically, WAF is just the firewall between you and the web server. Okay, now let's answer the questions. What can be used to host static files and speed up clients' visits to this website? That should be CDN, which is content delivery network, correct? What does a load balancer perform to make sure a host is still alive? That should be health check. Explain something correct. Health check. Is that not it? Health check. Health. I didn't spell that correctly. Health. So there's an L here. Now, what can be used to help against? What can be used to help against the hacking of a website? That should be WAF, application firewall. Tax tree. Okay. Tax tree here is how web servers work. Now, what is a web server? A web server is a software that listens for incoming connections and then utilizes the HTTP protocol to deliver web contents to its clients. The most common web server software you will come across is Apache, Nginx, and LLX and Node.js, correct? Now, a web server delivers files from what's called its root directory, which is defined in the software settings. For example, Nginx and Apache share the same default location of /var /www/html in Linux operating systems, and LLS uses the C folder /inetbulb /www root for the Windows operating system. So, for example, if you requested the file http /www.example.com/picture.jpg, it would send the file var www.html picture.jpg from its local hard drive. So basically, that's how it functions. Now, virtual hosts. Web servers can host multiple websites with different domain names. To achieve this, they use virtual hosts. Now, the web server software checks the host name being requested from the HTTP headers and matches that against its virtual hosts. Basically, these virtual hosts are just text-based configuration files. Now, if it finds a match, the correct website will be provided. If no match is found, the default website will be provided instead. Now, virtual hosts can have their root directory mapped to different locations on the hard drive. For example, 1.com being mapped to var www website_1 and 2.com being mapped to var www /website_2. Yeah. Now, there's no limit to the number of different websites you can host on a web server. Okay. Now we have static versus dynamic content. What are those? Now, the static content, as the name suggests, is content that never changes. Common example of these are pictures, JavaScript, CSS, etc., but can also include HTML that never changes. Furthermore, there are files that are directly served from the web server with no changes made to them. Dynamic content, on the other hand, is content that could change with different requests. Now, take for example a blog. On the home page of the blog, it will show you the latest entries. If a new entry is created, the home page is then updated with the latest entry. Or a second example might be a search page on a blog. Depending on what word you search, different results will be displayed. Okay. Now, these changes to what you end up seeing are done in what is called the back end. Now, with the use of programming and scripting languages. Now, it's called the back end because what is done or what is being done is all done behind the scene. You can't view the website's HTML source and see what's happening in the back end. While the HTML is the result of the processing from the back end. Everything you see in the browser is called the front end. Now, scripting and backend languages. There's not much of a limit to what a backend language can achieve, and these are what make a website interactive to the user. Now, some examples of these languages in no particular order could be PHP, Python, Ruby, Node.js, Perl, and most many more. Now, these languages can interact with databases, call external services, and process data from the user, and so much more. A very basic PHP example of this would be if you requested the website http:/example.com, index.php name equals to Adam. Now, if index.php was built like this, which is basically the HTML body hello, and then your echo gets the name, it would output the following content to the client: http body hello Adam, and so on. But this part is no longer there. You will notice that the client doesn't see any PHP code because it's on the back end. This interactivity opens up a lot more security issues for web applications that haven't been created securely as you learn in further models. Okay, now what does web server software use to host multiple sites? That should be virtual hosts. Sorry, I'm not looking. Virtual hosts is host. Yes. What is the name for the type of content that can change? Dynamic. Does the client see the backend code? Nay. That brings us to the end of task 3, and let's head up to task 4, the last task here, which is the quiz. Now, click the view site button. Let's do that. Hopefully it doesn't take time like it always does. Okay, great. Now, using everything you've learned from other modules, drag and drop the tiles into the correct order of how a request to a website works to reveal the flag. Now, note, when placing a tile in the correct position, it will highlight in green. When a tile is in the wrong spot, it will highlight in red. Make sure not to refresh the page, as it will reset the tiles or to blank again. Now let's do this. Now the first thing we always do is to of course just to request. For example, request tryhackme.com in your browser, and the next thing is to check our cache. Usually check your local cache for the IP address. If it doesn't have that, it will query root server. Is that it? Connect, check your DNS. Okay, the next is your recursive DNS server for address. If it doesn't find that, to now query your root server to find an authoritative DNS server. Okay, after that, it will head on to authoritative DNS server advises the IP address for the website. Okay, now what happens after that? It gets the website. This is now where we now start to connect to web server on port 8043. A web server receives the get request. I think this no, I think it's to connect. No. Okay, now yes, we need to request. The request passes through a load balancer because we need to go to a web server now. So no, web server is okay. Yes. No. Okay, firewall. So request passes through a web firewall. Then we'll have a load balancer. After that, web application talks to database. After that, no. Now it connects to a port. Then it talks to. We'll now finally talk to the web server to get the request. The web application talks to the database, and that's it. So basically, that's how it follows. Okay. Get a flag, and that's the end of this room. Alright, thank you for studying with me. Thank you for learning with me throughout this whole module of how websites work or how the web works. And we just concluded the last room, putting it all together. Next, we'll be going into another module on the web fundamentals. Stick with me, and do have a lovely day. Ciao.